Hi guys, we're going to be looking at a new meter from Peak Electronics today. This isn't the one, but this is the older model with fewer features. I'm sure many of you have got one of these. It's the Atlas DCA. It's a DCA75 and it is a semiconductor component analyzer. Sorry about the reflections on this. Probably haven't set up in the best position in the workshop today, so I'll try and bear that in mind. This has been out for absolutely ages, and it's very, very good. As I say, I'm sure many engineers have already got one of these, and there are a few limitations to this. Just comparing it to the new one, the newer version of this, which is the DCA75 or the DCA Pro as it's called. This one cannot handle insulated gate bipolar transistors. It can't analyse Zener diodes or voltage regulators, and there's a whole bunch of other measurements that this obviously can't do. Big feature on the new one is the fact that you can link it to a PC, and obviously you can't with this. So yeah, this is really a replacement for the DCA55, and this is how it arrives in the box. DCA55, as I said, and inside you have got a little sheet that you must read before doing anything else. You do not want to be plugging this into your computer before you've installed the software, and you should have the latest updates on the machine, etc., etc. This will run with all versions, I think XP, Vista and Windows 7, and I think I'll probably just do another video filming the laptop with the installation and use of the software. I have tried this, it works perfectly well, but I think we'll just cover that on another video. The booklet is much nicer than the old booklets that come with the other machines. In fact, I'll just grab one of those. The older booklets were not anywhere near as high quality as this new one. It's quite thick actually. There's a lot of information in here. There's about 45 pages. Excuse me, and it will just summarise its features and explain the standalone use and how to connect it up to your computer. I originally did a quick review of this, which I didn't post because I didn't bother to read the instructions, fairly stupidly, and I just dived in and started using it. I wanted to test the Zener diode reading facility and the voltage regulator facility, and I just got some perfectly good readings, and then on some Zeners and voltage regulators the readings were just wrong, and I just couldn't understand what was going on until I read the manual. And there are limitations as to what Zener diodes it can read. There is a maximum voltage of 12 volts. In fact, it says here, and if I'd read this originally, it would have saved me a hell of a lot of time. The DCA Pro may not be able to identify Zener diodes with a Zener voltage of more than 11 volts. It will, however, still identify the diode junction in its forward biased mode. Of course, I think one of the other things I was doing is I was trying to use this on 1.3 watts Zeners, and I don't think it's very happy with those either. Diode networks, obviously it can handle those as well. LEDs, it can actually light and test. Bicolor LEDs, the 2 lead types. Bicolor LEDs with 3 leads are handled. Bipolar junction transistors, obviously. All sorts of measurements are displayed for those. Freewheeling diode, faulty or very low gain transistors there. Depletion mode MOSFETs, enhancement mode MOSFETs, enhancement mode IGBTs. This is something that the old DCA55 could not handle, and it's quite important for the engineers these days. Voltage regulators, thyristors and triacs, and then it just goes into connecting it up for the first time, special functions, because you can update this online, and there's a test procedure, and all the regulations, all of the technical specifications are in this tables at the back. So yeah, there are some limitations to this, and you do need to read the instructions, otherwise you may get results that you weren't expecting. But generally it was fine once I understood how it works and what the limitations actually are. So actually inside the box you have a small USB dongle, and this actually includes the software for you, so you don't have to go off to Peak to download the software. You can just plug this into your computer and install the software straight off of it. I was just looking up online to see what the latest software and firmware is. The latest PC software that's available is version 1.0.4.737, and the latest firmware is 0007. So I would check at Peak Electronics website for the latest version before running this. Obviously as they ship these out, I'm sure they'll have the latest version already installed. This one arrived just after the release date, which was December 2012. So we're 3 months, down the road now, and I'm sure the software has probably been updated. But I'll actually check that in the video of the software that we'll do in a few days' time. So that's that. There obviously is a USB lead included as well for you to connect to the PC, and that is the unit itself. Exactly the same design as all the others. As you can see, it's the same size, pretty sure it's exactly the same case, and the only difference on this one is you actually have the USB slot in the top, and that's about it. But it does have a new display. I wish I could get rid of these. I don't know if that's going to show. Don't know what to do with the light in the way. Yeah, hopefully you can see that. This does turn off automatically after a period of time, and I'm going to have to do something with that camera. It's ridiculous. Well, look, hopefully you'll be able to see the display. Oh, grief. It's the problem with shiny surfaces like this. Yeah, it does turn itself off after a while. You can also just press and hold the off button here, and that will turn itself off. I've said in the past that I would love this to have a user variable on-off time, but none of them have. You can disable the bleeping noises that this makes, and details of how to do that are in the manual. So yeah, let's just run through a few components here and see what we get. We've got a 7809 voltage regulator. I'm just going to connect up. Doesn't matter which way you connect these leads. It will tell you once it's analysed the component what they're actually connected to. So let's just fire this up. Can't see this. Hang on a second. Let's try turning the lights around. I've just spun the lights around. Maybe that will make a difference. Yeah, hopefully that does. And basically it's saying red is out, green is in, and blue is ground. So it tells you straight away what the connections are. You can then scroll down for further information. Can't read this on the camera's little screen, but we have a list of pinouts again, and the voltage out in this case is 8.191, so pretty much spot on as you would expect. So no issues there. I've noticed a couple of odd little symbols. I don't know whether you're going to be able to see at the top of the screen there. A couple of funny little symbols. Hopefully it will pick up on camera. But I've noticed this on a few devices, or a few sections of the menu. You get those funny little squiggles at the top, and then not on other times. Next thing is V out, IQ 4.7 milliamps. Again, hard to get this focused and see it at the same time. Various other parameters that it's measuring. And eventually it will go back to the first screen. Oh dear, this is tough. Anyway, so that's the voltage regulator. No issues there. I tested a whole bunch of regulators, and I came across one that just wouldn't read. It wouldn't recognise it as a device. I don't really know why that should be the case, but it just wouldn't read it. Got a small red LED there, and 2-pin or 3-pin LEDs are fine. Just connect it with any two. Just going to try and get this so you can see it. This will flash. I don't know whether it will pick up on camera. There you go. I think hopefully you can see that flashing as it tests it. And then we've got a red cathode, blue is anode, forward voltage right around 1.924, 5.01 milliamps. So you can see that in there. Let me scroll down. Yeah, various parameters are shown there, and then it will go back to the original display. So that works perfectly, and it's nice that it does actually flash the LED for you. What else have we got? Well, let me run through a few of these diodes that I had working perfectly. And of course some of the ones that don't work perfectly. The reason I was particularly interested in the diode and voltage regulator measurements was because I wanted to back engineer some power supplies that were blown up beyond recognition, and I wanted to take another working one and just get the component values off of them. But if the values are over 11 volts, although I have found that higher Zener values do actually work. This particular one is a 7.5 volt Zener, but I think it's a higher wattage one, and I'm not sure it's going to work correctly, but we'll try. Yeah, in this case it's worked perfectly. Hopefully you can see that. It's telling us the Zener value as 7.38, and if we scroll down there are other parameters measured and displayed. Scroll down again, yeah, and then back to normal and the way it's connected. So yeah, that one was fine. So that's 7.5 volts with no problem. Let's just try a 5.9. Just fire that up. So right, now this is an example where it doesn't work. This is a 5.9 Zener, but it's quite a chunky one, and the wattage seems to mess with the measurement. As you can see on the screen there, it's coming up as a 4.74 Zener, which if we were trying to back engineer anything would be of no use whatsoever. So you know, depending on the wattage, you're going to have to be careful of believing the reading that it's giving you. We'll just try another small one here. I think this is a 5.6. Again, doesn't matter which way you connect this. I can't read that. Let me turn it around. So this time 5.6, so absolutely spot on. But you'll notice it's physically a lot smaller, and that is not a 1.3 watt version like a lot of the ones I have in here are. Now if we go up to something that is too high a voltage, this is an 18 volt Zener. Again, I think it's one of the smaller ones, so it should be wattage wise okay, but it is not within specs as far as the instruction book goes. So yeah, see now it can't actually measure the Zener voltage, so it is just defaulting down to a normal diode, and it's just showing you the junction drop there. Yeah, there's no other screen available. It just thinks it's a normal diode. If we drop, right, let's just try this 24 volt. Again, I suspect it's just going to read it as a normal diode. Yeah, and it has. So there's no other screens available, just the voltage reading there. And then if we try this is a 3 volt Zener, but again chunky one, I think 1.3 watts or more, and just test that. Now this time it's read it as a Zener, but the reading is incorrect. Okay, I originally thought this is a major problem, but I think as long as you're aware of this situation, you can bear that in mind. I mean, I wish it would handle these bigger wattage diodes, and I also wish it would go up to higher than 12 volts for what we do here. Yeah, but the lower values are absolutely fine. Just got a few FETs here. This is an IRF BC40 we'll just plug in. Let's just see what that gives. So it's coming up, if you can see that. Don't know whether you can. Oh, there we go, you can see it there. It's basically saying it's an N-channel enhancement mode MOSFET, and it's saying red drain, green source, blue gate. And if we scroll, there are other parameters. You'll notice the symbol also comes up of what the device is, and loads of parameters, so you can see whether it's within spec. It's also handy for comparing types as well, different types rather. So that's that. Just try a normal diode on here. This is a 1N5408. So yeah, just normal diode, junction registered there. There we go. You can see that. So it works well. Just bear in mind the some of the pointers. You must read the manual with this. There are limitations, as there is with any device like this. I do like the display. It is very clear, but it is odd that you get these little squiggles at the top of some of the menus. I don't know why that is, and maybe that's been corrected in some newer version of the firmware. Let's just crack this open and show you the insides. There's something I would change on all of these meters. I've got I've got about 4 of the different meters here, and they all suffer from a minor issue in my view. Yeah, let me get this on camera for you properly. So standard case, and if you ever damage one of these, all of these parts are available. You can get new transfer new stickers for the front panel. That is fairly easy to mark, especially with solder flying around maybe. So a quick look at the insides. Strangely, this now uses a 1.5 volt battery. As you recall, the other meters I think all use 12 volt batteries. There's obviously a DC to DC converter fitted here. That's the back side. It's close enough for you to have a look. I think this is based, let me have a closer look. Yeah, this is one of the microchip PIC 18F4 7J53s that's running all of this. There's the USB port up the top there. Again, nicely designed like all of the others that they've made. No particular issues apart from the fact that, like all the other meters, this screen is just floating. It's soldered in this side. On the back there you can see the solder, but the screen itself is just left to potentially move up and down as the meters put down and picked up and things like that, and long term that may well result in a few dry joints possibly. My idea, and I'm yet to do it, but we might as well do this on this one, is just to get some double-sided sticky foam and cut a small piece off and sling it in underneath the display. Probably some tweezers or something would assist in this. Yeah, so, and I haven't pushed it under perfectly, could have gone under a bit further, but that has now stopped that from flexing up and down and bouncing around. And it's certainly a modification that I would do on all of the other meters just for long-term reliability. I don't know why it's not done in the factory really. It does stop that moving around. So yeah, I would certainly do that. I suppose if you're being picky, if you look at the connections there for the three wires, I'm just going to have a closer look. Yeah, I mean, whilst they're very nicely soldered, the holes do actually go through the board. So I would have preferred to have seen those wires going through the board and soldered on both sides. Obviously that's a bit more fiddly to do in the first place, and there may be a damn good reason why that hasn't been done, but it's something I would rather have seen, just for the strength. If you pull one of these leads too hard, or it gets trapped and you pick the meter up and yank it, although there is a lot of solder on there, you can't really see the pad area very well, how strong that would be, and that could just rip the pad off. I suppose I should unsolder these and just have a look at the pad area, but I would much rather have seen the wires go through, because it does look like they're plated through, and it could have been fed through, soldered both sides, and I think that would have been a lot stronger, and would have put any tension, if you give this a yank, it would have put the tension through the plating rather than just onto the pad. But two minor points really, but yeah, would have been nice if they were slightly different. So that's it really. It was just a quick look at the meter. Nicely made, works well. A couple of limitations. Not really sure why a 1.5 volt battery was used instead of the 12s. Might have a word with Peak and just ask them about that. A couple of members asked this week if there was any forum arranged discount. Well, there isn't at the moment, but after this video goes up, on YouTube, I may well contact Peak Electronics and see if we can get some sort of discount arranged for forum members. So yeah, you know, overall pretty good. Don't forget this does plug into your computer, and you can get a lot more readings up on the computer. The website describes this fully. I would definitely have a look at that before buying it. Don't go just on what I've said. Have a look at the pros and cons, and also have a look at the differences between the DCA55 and this DCA75. There is a comparison chart. I didn't read off all of the things, you know, things like JFET, transconductance, and a whole load of things like that. I'm sure nobody wants to listen to that on YouTube. Just go and have a look at the specs online, and I'll put the links in at the bottom of the description on YouTube. So yeah, sorry, dragged on a bit, but just wanted to show you this. Just quickly go over some of the things that it will do that's different to the DCA55, and yeah, hope it was useful. Catch you later.